Now, we will be working out the oxidation states of elements in compounds. So first of all, we must start with the correct formula, and then we will write the oxidation numbers of elements that we know from the rules that we have studied before. And then we will figure out the oxidation states of any other element. Let's solve some examples together. The first example is phosphorus pentachloride, PCl5. So in this compound, we have one phosphorus atom and 5 chlorine atoms. And this is a neutral compound. So the sum of the oxidation numbers of phosphorus and chlorine will be equal to 0. From the rules, we know that the oxidation state of chlorine is equal to -1. And we have in this compound 5 chlorine atoms. Let X be the oxidation number of phosphorus which we need to find. So back to the rules, the sum of the oxidation numbers of all elements in a neutral compound will be equal to 0, and thus X plus 5 times -1 is equal to 0. So this is the oxidation number of phosphorus, and this is the total of the oxidation numbers of chlorine. So we have 5 chlorine atoms and each of them has an oxidation number of -1. So X minus 5 is equal to 0, and thus X is equal to 5. So the oxidation number of phosphorus in phosphorus pentachloride is equal to +5. Let's take another example. Ammonia, NH3. So in ammonia we have two elements which are nitrogen and hydrogen. From the rules we know that the oxidation number of hydrogen is equal to +1. And this is a neutral compound, so the sum of the oxidation numbers will be equal to 0. So let X be the oxidation number of nitrogen, which we will find now. So X plus 3 times +1 is equal to 0. So we have one nitrogen atom and we have 3 hydrogen atoms. So again, X plus 3 times +1 is equal to 0. So X plus 3 is equal to 0. And thus X will be equal to -3. So the oxidation number of nitrogen in ammonia is equal to -3. So let's check. -3 plus 3 times +1 is equal to 0. So the sum is equal to 0, and thus -3 is the correct oxidation number. To double check, we know that nitrogen is more electronegative than hydrogen, and thus nitrogen must have the more negative oxidation number. So -3 is the negative oxidation number and +1 is a positive one, and thus the oxidation number we have found is correct and follows the rules that we have studied. Let's take another example. Now we have nitric acid, HNO3. So now we have 3 elements in this compound, which are nitrogen, oxygen, and hydrogen. From the rules, we know the oxidation numbers of oxygen and hydrogen, and thus we are left with nitrogen and we have to find it. So let X be the oxidation number of nitrogen, which is unknown. From the rules, we know that the oxidation number of oxygen in such a compound will be equal to -2. And from the rules also, we know that the oxidation number of hydrogen will be equal to +1. Nitric acid is a neutral compound, so the sum of the oxidation numbers will be equal to 0. In this compound, we have one nitrogen atom, so we have X, and we have 3 oxygen atoms, so we have 3 times -2, and we have one hydrogen atom, so +1. So the sum of these oxidation numbers will be equal to 0. So X plus 3 times -2 plus 1 is equal to 0, which means that X is equal to +5. So the oxidation number of nitrogen in nitric acid is equal to +5. Notice that nitrogen may have different oxidation states in different compounds. So in this case, in nitric acid, the oxidation number of nitrogen is equal to +5, which is positive. However, in ammonia, the oxidation number was -3, which is negative. And in this case, oxygen is more electronegative than nitrogen, so oxygen will have the more negative oxidation number, which is in this case -2. So one important note to keep in mind: when assigning oxidation number, you must specify the compound. So it's important to say that the oxidation number of nitrogen in nitric acid is equal to +5.